Hey guys, today it's Milk Chemistry Monday, and today I'm joined by my mom.
Hello.
And today we're going to be doing the rocket fuel experiment.
Rocket fuel.
So it says that we're going to need a big spoon of CaNO
CaNO 3, 2.
and K4FeCN6.
K4FeCN6.
This is that we'll need this tub thingy.
What do they call it? A candle holder? Oh, no. Empty candle holder. We're going to do... Wait, let's read what we're doing, Pua. Sir, Aiden. And let's get safety ready. We're just ready to experiment today. Safety. And these are mine because they're little and cute.
No comment.
Okay. So we are getting safety ready right now, as you can see. It's always a good time to be safe. Always a good thing to be safe. No, we got sensitive skin. Gracias.
De nada.
Grazie. Okay. Ready. Okay, so let's go over the items. Did you get all the items together?
Yep.
Okay. Can I use these directions? Then when we get to that part, we'll use those to color and stuff. All right, let's do one at a time. Let's just do step by step because these they kind of go together. This one is like a step by step one, and this one is like
just
a
broadly.
picture general direction set. So this is like for the kids, I guess, and this one's like for the parents, like make sure we get everything, cover everything. And this is so they can learn something too. It's like a cute way for the kids to see and learn the experiment. Okay, and we're ready. Okay, boom. Measure 1 big spoonful of CaNO3 into an empty candle holder from the set. Candle holder, boom, big spoon, and we're ready.
Okay, this looks like you just stick.
And it does say if the powder is stuck in the bottle, use a wooden stick to knock it loose. Just stir it around, loosen it up. Boom. Okay. Add 1 big spoonful of K4FeCN6. Big spoonful of coming. Oh, are we still on the first one? Oh, we spilled some.
Oh.
That's okay. Let's use some of that. It's not coming out? Shake it. Shake it.
Yep.
Okay. Well, let's get that in there. Oh, yeah, we got gloves. Use your fingers. I thought with the spoon, but, let's give it. Let's see what happens. Oh, I guess. Alrighty. Okay. Then we're going. Well, I'll get this up while you do the next spoonful. Okay. And add 1 big spoonful of K4FeCN. So this is the second one. This is the
yellow stuff.
We still got a little bit left for another experiment if you wanted to. Because we do them a couple times, sometimes.
And make sure that you always have enough to do an experiment next time as you're doing that experiment, or maybe later, so that when you go looking for this stuff, you're not disappointed.
Because he likes to do them at least, well, I like to do them at least 2 times. Each one, at least 2 times. Okay. Oh, I guess I can get these on, Nisha, because we all want to be safe. Completely safe. Goggles and eyewear. Pardoname. Okay, so stir the mixture thoroughly using a wooden stick. So we're stirring the CaNO3 with the K4FeCN6. Let's go. Stirring, stirring, stir. So, stir the mixture. Did that, boom. Okay. And take off your protective gloves. Insert 1 candle into the stove and light it. So, after all that, we're like halfway through the experiment. They're going to say, take off your gloves. We're going to wait to do that and see why. place the flame diffuser on top of the stove and place the candle holder with the mixture on top of the flame diffuser. So, flame diffuser. Let's get the flame diffuser out. That's our oven. This is our candle that we've lit already since we've seen it required fire. And I will go ahead and place this here. You didn't have to have it lit. You could just, grab the torch or a light or whatever and lit it. But we just want to have everything ready for you guys. Okay. Slow it down, boy.
Okay.
Aiden, Baden. Yeah. You gotta look at all four corners. It goes, there you go. Almost.
There we go.
Perfect. It's like it goes in and out a special way. Okay, so. Oh, it doesn't take off your gloves. Sorry. So you don't want anything to catch fire. Yeah, alrighty. So okay, I will take off one glove just in case I want to help again and touch something over there so I don't get anything on fire. Maybe, I don't know if, any other items we have, or if they're like, if we touch the little cubes or the powder mixtures, if it makes it more susceptible to burns, we're going to take off the gloves like it says, because you're going to be still working with the experiment. So take off your protective gloves, plural, both, and leave the okay, wait, yeah. So we did all that, place a few more on the top of the stove, place that in there, boom. Leave the mixture on the heat for 15 minutes. Where is your phone, sir?
Right there.
Let's do a 15-minute timer.
Thank you.
Grazie. Okay.
I just recently changed my password, so I'm used to that old password.
Cool guy. Okay, so we're gonna let it go on a spin about 30 seconds. Timer. It's slide up. It's always right there, good butt. Okay. Timer. Boom. Let's go. 15 minutes is it going. Okay. And we will hear it. So it says blow. No, after 15 minutes, we're going to blow the candle out and light a wooden stick. So while it's burning, let's just go over what this is all about. You want to read it or you want me to read it?
I do paragraph, you do paragraph, I do paragraph.
I like how you're thinking.
Okay. When burning something, you usually care only about the fuel you're using, whether it be wood, candle wax, or coal. Any burning, however, requires two ingredients, a fuel and an oxidant. An oxidant is a substance that wants to take electrons from the fuel, which is eager to give these same electrons away. Usually, the acting oxidant is oxygen in the air. But if you want your fuel to burn without air, you have to include your own oxidant too. This is how space rockets work.
Ooh, I like that. Nitrates such as the calcium nitrate, CaNO3, that we use in our experiment are convenient oxidants because they are solid and easy to store. As potassium ferrocyanide is the K4FeCN, looks like that's the official name. Potassium ferrocyanide doesn't burn very well. It is not often used as a fuel, but in combination with the nitrate, it makes a decent fuel for small model rockets and fireworks. Okay, so choosing a good oxidant fuel pair for a rocket is pretty tricky. You need to be able to store and transport both ingredients.
Hey, you're in my paragraph.
Oh, my bad. Make them react energetically, and you can take over from there.
But not energetically enough to explode, and take many other factors into account. The principle is always the same. An oxidant takes electrons from the fuel with the release of energy.
Ooh, the principle is always the same. An oxidant takes electrons from a fuel with the release of energy. So it gets some of its energy with the release of energy.
Kind of like a parasite.
It takes electrons from a fuel with the release of energy. I like. How many minutes were you at so far?
12 minutes and 35 seconds.
Okay. It says when we're all done, dispose of the waste with your household garbage. So it's not really anything super,
It's not too toxic.
an active ingredient that you have to dispose of a special way in a special bag or a special container or anything like that. You can just throw it away in the garbage. And keep your hair flammable objects away from the flame. Got it. And it says this is a rocket fuel experiment and it takes about 20 minutes in total. So this is telling us about different things that burn things and the different ways they burn. Right? Different things that burn and different ways they burn.
I think it's more. I think it's teaching us more about how fire uses its fuel, I guess.
Fire uses fuel?
How fire uses its fuel.
Okay.
Like certain things.
Different kind of fuels?
Yeah, different kind of fuels will change the fire's outcome. Like, for example, when we did the burning magnesium experiment,
right,
that made the fire white. And how we did the green sparkles experiment, when we used the copper stuff, the fire turned green.
It was green.
So this, well, I think that just the flame thing in general is just over how flame uses its fuel, or what reactions go on
with fire and in fuels and interesting. An oxidant. Any burning, however, requires two ingredients: a fuel and an oxidant. So everything that burns requires a fuel and an oxidant. So when you see a fire, we know that to get this fire burning, we needed a fuel and an oxidant. To start a fire in a park, as a Boy Scouts, we need a fuel and an oxidant. If there's no air around, if you're in a tunnel, what could be our other oxidant
We could use leaves, animals you find in there, dry objects in general. Well,
so you have to, give me examples. But I'm just saying, like, that's just like the
mindset,
right? The idea, the way we was rolling with that. And how many more minutes we got to go?
9 minutes and 55 seconds.
Okay, so let's start on it. Oh.
Sticky?
No, it's getting hard. Guys, it's getting hard. Ooh. And it's a little hot. It's cooking. For real. Okay.
Cooking with chemistry.
Cool. I would touch it too. But I got them cooking hands where you can grab stuff almost out the oven, bare hand. Almost. I see it. After it's been chilling for a little bit. But I ain't trying to do that today. I'll get them though. Okay. Looks like it's we try not to, it's getting darker on one side. That's why I started stirring it, because it looked like it was starting to burn. Okay. You're going to give it 10 more minutes, or 9 more like the machine. Like the countdown timer say.
Dang, that minute went by real quick. We're at 8 minutes. 8 minutes 55 seconds.
Step by step, we did that. We did on plastic tray. This is probably our longest experiment ever so far.
Definitely.
Yeah.
This is gonna be our longest video.
Oh, that's cool. That's cool.
It might be. We haven't gotten our new shipment yet.
Yeah, because there's more to come. Our new one's on its way. Ooh, 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 ooh. Oh, yeah, we have one more, though, in this box. Did we did them all?
Yeah,
all 3?
The last one.
Okay, how cute is that? And the next one's on its way in perfect timing. Wait, we didn't do the wire one.
Yeah, we did. That was that big one with the white flame.
Oh, okay. Okay. We'll... Okay. Yeah, I think we're going to be doing this one next, Boo.
Okay. The wire that came with it.
We only have one.
Yep.
Right. That's what it was. So we did burning magnesium in our spare time because, okay, we like to just do the experiments, okay? And then we like to do them one time, for everybody. So what happened was, with burning magnesium, they sent one of the little wire copper things that we had to burn during the experiment. And so we didn't get to show that one to you guys. We just did it one time, and I think we thought we recorded it, and we were using Aiden's phone, and
we ran out of storage, and then it stopped over 3 minutes.
Right, it was there were complications. We're learning how to record and get these up and uploaded and everything, but So just keep this in mind. If you guys are thinking about getting these, they sometimes will send you, like, with certain experiments, one cut of the experiment. Like, you only get one take. And we're so used to just going and doing them, like, oh, we'll do it again. The second thing, no, we'll do it even another time sometimes, that we didn't even think they might not have enough for a second time. So just, if you just keep that in mind. If you're like us and want to do the experiments more than once, yeah, check and make sure you got enough supplies to do them at least 2 times. If you're doing it for a purpose or for a friend or whatever. Okay, let's see what else we have going on here. Boom, boom. Okay, about 5 more minutes. We're just gonna boom, boom, 5 more minutes. And it's still...
If you take wax and solidify it and you light that wax on fire,
Mm-hmm.
and you drop that wax, will that wax be on fire?
Wait, if you... Say it one more time, wax?
Like, if we took some more wax from the candle,
Yes.
we put it on the splint,
Okay.
we let that on fire, then the wax falls off. Will the pieces that fall off be on fire?
The wax?
Yeah.
Because that wax is a fuel, probably. It's gonna be still, unless it's burned off or whatever it was on, it's probably gonna keep
Using the wax.
as the
That
fuel.
explains why. Because this, by now, probably would have been ash. And that wouldn't really even be there. That's like basically charcoal black.
Take it. Anything else that springs to mind? No.
Is it just me or does this look bent?
What is it? Very possible it could be bent. I think it's this whole thing we just kind of like, maybe the whole area is like tilted. Try to hold it. Go ahead. Stay. Boom. Done. Start again. Boom. You started the same. Okay. I don't like it started. Look like it's getting a little brown. And we still got some time to go. So, just trying to make sure everything get all together the way they want it to be now. I guess I could stop
4
putting
minutes and
glue.
30 minutes. 4 minutes and 30 seconds.
4 minutes and 30 seconds. Ignite your own rocket fuel. So this is like a mixture similar to what rocket fuel will be like.
There's nothing in space, right?
But they gotta still light the rocket before it gets out in space.
Yeah, well, like...
Well, yeah, there's no air in space, right? That's what you're talking about? There's no carbon?
I mean, like, there's nothing in space besides the hydrogen stars are made of, right?
Right.
And the planets.
Right.
So when they're flying through space, why are the spaceships pushing backwards?
Why are they pushing backwards?
No, what are they pushing backwards?
That's a great question. Let's look it up on your phone. Because we got Google. Yeah, dude.
Oh, yeah.
What? This guy and his passwords. Okay. Where we at? I'm just searching.
What do spaceships push backward in space?
How does a spaceship fly in space, maybe? Something simple, you know. Our timer's gonna be going off in a couple minutes. You got time? Search that in 3 minutes, I'm sure. We've searched things in less time.
Which rockets are usually used to...
Louder.
Retro rockets are usually used to
decelerate,
not steer spacecraft. They operate like any rocket engine in a vacuum of space by propelling gases in one direction to create an opposite and equal force on the craft. There is no need for air of those gases to push against, thanks to Newton's third law of motion.
There is no need for air to those gases to push against, thanks to Newton's third law of motion.
I should have realized
What?
that when you're... I was thinking about what I just read, and I was like, oh yeah, so they probably have to push out the gas, and they push against that. Like, kind of like,
Okay, creating their own momentum to push against. Oh. Interesting. Last 2 minutes. Okay. So, I don't know. I mean, overall, I think these are cute sets. I mean, they're cute sets. The babies learn. You know, and that's all we can ask for. It makes them curious, gets them thinking, which I love. Just to be thinking, critical thinking, period, is wonderful. Igniting just the want to know things, you know, the want to try to figure things out. I like the want to try things, you know, to not be afraid to try something, mess it up. Okay, oh well, let's try again. Because that's what everything's all about, right? Trying stuff. I might mess it up. Oh well, okay, it happens sometimes. I'm gonna try again. And I'm gonna probably excel that time. If I have to try again, I'm gonna excel. You dig? But, okay. Welcome to the wonderful world of chemistry. It's just a cute, I just like it. I don't know, maybe because there's not much, you know, people, there's not many programs or things like this out here for science and for kids, or not necessarily kids, but teenagers.
12,
So, I'm all for it.
10, 9, 8.
You got a 10-year-old?
6.
What did I say, 10?
5, 4.
Yeah.
3.
I would get it for him.
2, 1.
Okay. So, 15 minutes is out. Wait. You said blow the candle out, but we're not going to do that. We're going to light the one stick first. It's like the other side we ain't messed up yet. It's not like the same side. But first, it just say light it. Didn't it tell us dip it in something or something like on this one?
No, that was the
Oh, the other one. I'm mixing up experiments. Okay, here we go. Light the split. The stick. We're lighting the stick.
Oh, wow.
Oh, shit. I mean, on Snapperdoodle. Okay, you probably need a fresh stick. Let's break it. Here, boom. Now it's fresh in.
But the thing went on.
Okay. I did say I was gonna light it, didn't I?
Mm-hmm.
Yeah, okay, here we go. Be right back. Got the light stick. Shoulders back. All right, so we are going to light the whatchamacallit.
Rocket fuel.
Rocket fuel's lighting.
Oh, whoa, okay.
Oh, shit. That scared me. Okay.
Burnt marshmallow now.
So, that was real. That was a lot. I was not ready. I did not see that much fire the first time we did it. Okay, it says caution, very hot. We did not believe the hype, but it did pop. Okay, it got big, and that was like burning or lighting a rocket fuel. Wow, it was purple and pink. Wasn't it purple and pink?